Hey, John here. Welcome to the other half of my basement that I normally don't show on the YouTube channel, where we have the water heater and three 19-inch racks that a prior employer was going to scrap, and I borrowed a trailer from a friend and decided to bring home. This is really nothing more than a closet where I just store stuff, but it looks cool. I have three racks. Awesome, right? Now, the one on the end over here is what I like to think of as my museum of computational antiquities. All right? So, starting from the top, we have an S100 bus Integrand system that I used. This is the cabinet that would have held this board, which I've shown on my channel before. This is my homemade Z80 2 megahertz system with 2 serial ports that I designed my freshman year in college, and this was my daily driver for 5 years, okay? Possibly more. I don't actually remember which years was what. I know this one started in 1981, and it probably booted for the first time in 1982. It was eventually replaced by this down here, which is an Altos ACS 8000 series machine with 2 double-density, single-sided 8-inch floppy drives. This was purchased from its original owner, a friend of mine. She wanted to get rid of it in the late 80s. She didn't really have much use for it anymore. And I bought it because this system has a 4 megahertz Z80 in it, so that's a 100% speed increase over my homemade Integrand system, okay? Plus it had double density floppies. My homemade system only had single density floppies. Down here we have a Televideo 9 Plus that came with the Altos. All this stuff works, by the way. This is running right now. So these are two IMSAI 8080 machines. They have radically different serial numbers, and the power supplies inside them, the way they're cabled up in the back planes, the way the holes are knocked out and everything else are noticeably different. So they're different eras of manufacture from IMSAI. They both run, but this one has a bit of a problem, and that's why we're here today, okay? The bottom one here is in very good shape. I think both of these were gifted to me by friends over the years. This one, I think, was literally scavenged out of a dumpster. This one down here is in very much noticeably better condition, in spite of the fact that, by the way, if you watch my channel, this came originally paired with this digital systems unit up here that I tore apart and showed on my channel. I don't know, a year or two ago. I filmed myself opening the lid of this, and it was filled with, let's just call it a mouse latrine, okay? The only thing that I was able to salvage off of this system was the metal box and most of the power supply. I had to recap the power supply because, not because the capacitors wore out, but because the mouse ate holes in them, or mice. There had to be many mice in there. They completely ate half of the floppy disks as well. The drives in here now are not original. These are Siemens disks. This case originally would have had, did have, and I got rid of them, shoe cart drives, the same kind that are in the Altos down here, okay? These are the Siemens drives that I used to use with my Integrand system, and the reason they're in here is because the other ones had the entire things were gutted by mice. I donated those to someone I met at Vintage Computer Fair last year, and they were grateful to have them, and one of them was pretty close. They'd probably replace a belt and maybe 1 or 2 of the cables in there, but it looked like it would roughly run if the guy cleaned it up. The other one that was in here was just completely destroyed. Everything about it was ruined, okay? And the main circuit board in there I showed on my video as well, totally covered and completely rusted out and rotted away due to what is most likely mouse urine and feces all over the whole thing. So there was nothing really salvageable about it. It was a biohazard, right? So anyway, I put my old drives in here just because, you know, I am running out of space and it looks good. Plus, the original case for my old drives was made out of plywood, probably in a shop class somewhere, and it's too big to fit in this cabinet. I still have the pieces, and if somebody ever donates a pair of proper drives that makes this look correctly, I'll probably take these back out, put them back in the wooden case. Maybe I'll bring them to Vintage Computer Fair in the fall. I don't know. Just for fun. Okay, so why are we here? IMSAI 8080s. All right, so let's zoom in on these so we get a closer look at what's going on. All right, now these, I absolutely love the 8080. I think it looks great. They're beautiful machines. The only problem is, as you can see, is these panels are shiny and have a lot of glare. So I changed into a black shirt here. My shirt was just reflecting all over the place. All right, so what's going on here? This one doesn't work correctly. This one down here does. They both are plugged in and are fully serviceable, and they both make a lot of noise. So I hope this actually is getting picked up okay in spite of all the fan noise. Let me power this one off. So we only have one set of fans going at a time. Let me show you one that works. Then I'll show you what's wrong with this one, and maybe we can figure out why. So, what do we got here? You power this thing up. You've got all these switches that control your ability to read and write 1 byte value at a time into the memory that's inside this system. It also allows me to tell the CPU to branch to a specific address, and I can single step one instruction at a time, or actually one memory data transfer cycle at a time. We'll talk about that in a little bit more in a minute. But here's the deal. If I can modify the bytes in the RAM memory of this machine and then aim the CPU at it, we can watch it fetching and executing instructions one at a time, and we can see what the CPU is doing based on the status lights over here that tell me that I'm in machine cycle number 1, which means the CPU is fetching an opcode, versus other machine cycles that have, or time cycles I should maybe say, where the CPU is reading just data in from the memory or writing data out as operands for an instruction or a load or a store operation kind of a thing going on. These switches over here control all that. So let's write a program, type it in, and see it work on here, and then do the same thing on this one and see what the differences are. When you power this unit on, I haven't really done anything yet. It comes up in wait state. We'll take some closer looks at all this in a minute and talk more details about how these things work. Bird's eye view first. When you first power it powers up in a wait state. It's held off. It's not running yet, okay? I can key in a program. Let's say I want to look at the value that's in C0 in hex, or 00C0 I should say, that being your address. I can click this up and say examine the value stored in memory at this address. You can see on these LEDs down here the current address in binary, and this is the value that's currently stored in there when the power came on. Presumably garbage, okay? If I want to change the value that's in there, maybe I want to change it to CC, okay? I can key that in on this set of switches here. These are ignored during this operation. I can click this switch up and say, please deposit this binary value into memory at the address that's still on these LEDs down here. Okay? If I want to change it to say something else, I can put a C0 in there, or I can put a C1 in there, whatever I want. Okay? Then I can click this down, no matter what the state is on these switches, and it'll say, show me the value in the data in the memory at the next address. You'll see this adding one, adding one, adding one as it goes along into successively increasing addresses, and I can watch in binary and have a look-see. This is how you get yourself a binary dump of memory, 1 byte at a time. Okay? So, all the switches down, addresses are 00. I can examine the value that's at that address. I clicked it the wrong way. You click it up and it says show me the byte in memory up here that's stored at the address on all 16 of these switches if I say examine the current value. And again, I can click it down, say show me the next value, okay? 1 byte at a time. I want to change it, I want to say this is an FF, I want to change it to a 00, I can say deposit with this one like I just did before, or I can say deposit next. Now what this switch does when I hit deposit next, it says deposit the value on these 8 switches into the current address that was shown here, then add 1 to the current address and show me the value at that new address. So if I just leave these down and I keep hitting deposit next like this, what I'm really doing is zeroing out all the memory. Okay?
I think I actually said that backwards. I think what it really does is it adds 1 to the address, then it deposits the current value on these switches. Yes, it does, because if I click this up right now, you can see the 0 that I left at this address, which is a 1, 2 in hex, and I hit deposit next, and we move over to 1, 3 in hex, and you can see there's a 3 stored in there because these switches are up right now. Switch them back down, and now I can store a 0 into the next address there. And I don't know how well the camera picks it up, but you can see the lights flicker briefly with the old value before it deposits the new one. All right, so sorry, I said it backwards, but yes, that's how this thing works. So let's write a little program here. Go back to address 0, all switches down, and I'm going to just deposit a bunch of zeros in there and 0 out our memory, so we don't have a bunch of garbage coming up on the data panel up here. If I go to examine, and I hit examine next, I'm just looking at the current 1 byte at a time from the first 0 through 1, 0 for 16 bytes of memory that we just watched go by. They're all set to 0 right now. Now, if I say deposit a bunch of zeros into memory and then move on to the next, oops, I clicked the wrong switch, that's not good. Examine 0, okay, deposit a bunch of zeros in there, okay. And then I eventually say C3, which is the opcode for a jump instruction to an absolute address, and I say deposit that in the next address, okay? So that's stored at address 7 in hex, there's a C3. And then I say the next byte, I put an 01 in there at address 08 in hex, and then I go 00 at 09 in hex, okay? What I've really done here is I've written a spin loop, okay? If I hit examine, back to address 0, and I walk through the memory 1 byte at a time, you can see the program that we downloaded. There's a C3, there's the 01, and there's the 00. This is a little Indian machine, so that immediate operand have the bytes backwards. So what I really said is jump to 0001, even though the bytes are stored backwards, okay? If I hit examine 0, among other things, among showing me the data, what I've done is I've said if I run the CPU right now, or single step it, it will step from this address. This is the current address in the program counter in the CPU when I've done this. So if I click this switch up or down, it doesn't really matter, I am single stepping the CPU, and that means fetch 1 byte at a time and execute what's there. So M1 is on. That tells me that if it's going to fetch a byte, that byte will be treated as an opcode by the CPU and not an operand or some other load or a store type of thing. So I click it. It read it in. It was a 0. We all know that's a no-op for the 8080 and the Z80 and the 8085 processors. So we execute it. We go back to M1. We're reading another opcode because it's just a single byte opcode. And you can see it just keeps on going 1 byte at a time because each one of those single byte instructions is a no-op. Till we get to address 07 in hex, all right, and it shows it before you execute it, right? So I'm in machine cycle number 1. There's a C3 in there. We know that's a jump. We know it has 2 bytes of immediate operand values. So if I click single step, what it did is it engulfed the operand. M1 shuts off to let me know it's reading the data, not because it wants an opcode, but because it's involved in executing the instruction. First thing it needs to do for C3 is fetch the immediate operand. So there is the the least significant byte, and you see it reading the most significant byte from the following 2 byte addresses. We'll now execute the instruction, and then it will do the branch, and it'll go back to address 1. So if I click this now, you'll see the address goes back to 1. M1 comes on to let me know it's fetching a new byte, a new opcode, I should say, and we can see it going around and around. It got the C3 again, the 01 and the 00, and it branched once again to 01. So this is running the program as one would expect, given this basic amount of information we have to go with. I can click this button up here that just says just run this program continuously. Okay, and when I'm running it continuously, you can see that the only memory addresses that ever show up down here are these bytes between 0 and maybe F. These are flicking on and off very quickly. The data bus has other things going on it as well. It's used for various things. They multiplex the data and the address lines together for this particular processor, so there's going to be all kinds of noise and chatter on the data bus. The address bus here, though, is a pretty stable thing, and since no one's addressing any bytes of memory greater than these low ones where we put our little loop, those are the only address lines that are coming on. You see M1 on here. These are somewhat dark. They're going on and off at, a million times a second kind of a thing here, okay? I click this down. I can stop the program wherever it is when I click that. It happened to be at address 1, fetching the no op. If I run it again and stop it again, you can see it's going to stop it at random places along my program because I can't time it just right and stop it right in a specific place. So if we run it and stop it and run it and stop it, statistically we'll find a couple of different places where it stops. It looks like our favorite place to stop is at address 1 and 3. When we stop it, we can continue by single stepping if we want. It's reading some more no ops followed by the jump, and again it'll go around the horn, and we can pick up where we left off. Even after single stepping, we can resume from where the single stepping left off. This is proper operation of an IMSAI 8080 for a program of that type. Now let's fire up this other one that's not quite copacetic. So we power it up. It's waiting, just like this other one did. We do not have M1 on here. One of the things I should have showed you before, if you hit reset, every one of these LEDs over here are supposed to go on. We see the M1 is not on, and this data bit number 5 is also not on. So it's our first problem that's wrong with this thing, okay? Now, if we examine the bytes that are in the memory and we will examine next, you see it counting along. And while this LED doesn't work when the reset was on, it does go on and off now. So it's not like the LED is burned out. So maybe there's some clues there. I don't know. And I'm not making it up. I don't know what's wrong with this darn thing. So that's what we're going to have to try and figure out. If we go through and examine these values, we can see them coming up. Let's go ahead and deposit a bunch of 0 values into the memory if we want to, and go back and see if that got stored in the memory. Okay, so we can change the bytes because they were on and off. Let's put a 66 in hex in there. Go back to address, I went to address 66. Go back to address 0 with examine, and now we can deposit that in at address 0. We can see there might be a 66 in there or a 46 because this LED is flaky. We don't really know for sure. Let's just deposit a bunch of these values over and over again. Okay, then go back and examine address 0. It still says 46. It's not clear to me whether I got a 46 in there or a 66. I don't know. If we go back to address 0, deposit a bunch of zeros back in there. Let's run our same little program again. Examine address 0. Look at that, it didn't even take it. Let's go back to address 0. All right, so something's wonky with the deposit next, right? If we go to address 0 and we put an F0 in there and I deposit that in address 0, again, the light's weird, but we have and you can recognize why the lights are the way they are in spite of the fact that this one here is not working. If we go back to examine, oops, I got to put 0 on the address bus in order to examine address 0. See the byte we just stored. We either got a D0 or a whatever, an F0 in there, depending on whether the LED is bad or the memory. I don't yet know. We can walk through memory. And we have one byte that's got some value in there and then a bunch of zeros. So let's go back to this F0 and hit deposit next many times and just keep depositing an F0 into memory there, right? Go back to address 0 and examine next. So we're consistent. So the deposit worked when we're at address 0. And the deposit next worked to deposit and then move on to the next address. But not quite, right? Let's go back to examine address 0. Let's put a 07 in this. Replace either the D0 or the F0 with a 07, all right? If I hit deposit next, what it should have done is deposited. Is that right? Maybe it didn't work because I'm not doing it right. I forgot. I keep forgetting. Deposit next means add 1 to the address and then deposit. It should have said next deposit. I keep looking at, even to this day, I've had these for decades. I get it backwards every time. It's go to the next address, then do the deposit. Okay. So that's why the first byte didn't work right for me. So I go back to address 0, and I've got my F0, and then I got my 07. Okay, and we got more F0s. Okay. Fine. So that does work. That was a an ID10T error on that one. Okay, so we're back on address 0. We don't know whether that got stored right or not. Let's go back and deposit a bunch of nulls, a no-ops, okay? Go back to the examine and examine next. Okay, so they're all zeros as far as we know. And then after a while, we got some other garbage in there. Let's write a couple of no-ops, put in a 0, followed by a couple of zeros. And then when we get to address, whatever this is, write 4, put in a C3, which of course went into address 5, as I'm relearning how to operate this darn thing. And then we'll put in an 01, and then we'll put in an 00, okay? Now it just so happens that a C3 doesn't need a 1 stored in this bit here with the wonky LED on it. So I'm going to go back to examine address 0 and go through one at a time, see my C3, my 01, and my 00. So it appears that the instructions are probably okay. Now, we don't have M1 on in here, and we have reset this thing. It still won't come on. Okay? Go back to examine 0 to make sure the state of things are okay. I know it is. If you'll reset, the address will be set to 0. If I single step right now, the CPU, as far as I know, will fetch the instruction at address 0 and execute it, which are our no-ops until it runs into the branch and does the looping thing like it did before. So if I click my single step, it is reading 1 byte at a time, and this is counting, which is a good sign. It got to the C3, which is our branch. We see this advanced. It didn't do something wonky yet. It advanced the address, and it's fetching the 01 and the 00 like it did before. Now, if it really is executing these instructions and not just somehow walking 1 byte at a time through memory, this address should change back to 1, which is the target address of our branch, which it did, and we can see it go round and round and round and round. And if I click run, again, we can see noise because of the huge amount of stuff at 2 megahertz or whatever the speed of this thing is running, which is 2 megahertz, plus it's interleaving the data and the address bus, because that's how the 8080 works. It shares the same data bus pins on the chip for multiple functions, so we get a little bit of noise here. No M1, but clearly it's running, and it's in a loop because it's only addressing bytes between 0 and 7, which must be where we left our program. So that's a good sign. In other words, I think the machine is working. The memory card that's in this machine is working because we're able to store things and get things back, but this LED does not go on, neither does the M1. So it just so happens that M1 is not really used by anything in this configuration because all we have is the CPU and memory, and the memory doesn't care why it's being read or written. So the M1 signal, even if it's like not connected, maybe there's like a broken trace or something on the CPU card, maybe it's not even connected to the bus, which is how these LEDs show these signals. It comes off the S100 bus itself. It may be that the CPU card doesn't even send this value. I don't know. As far as this goes, it's weird because sometimes the LED's on, sometimes the LED's off. We'll look more closely at this front panel, and you'll see that this data bit, the data bits here, come to the front panel through this ribbon cable right up here, not through the S100 bus. It comes directly off of the CPU itself from this special jumper cable. All right, so this really is working in spite of the fact that M1 doesn't work and this LED doesn't work. Now I also see that if I try to stop this, it won't stop either. I can't stop it once I've started it. But if I hit stop and I hit like reset at the same time a couple of times, eventually it stops. Go figure. I don't know why. Let's run it again and see if it'll... I don't know if reset will actually stop it or not once it's going. Let's fire this one up again and see what this guy does. And full fan mode. Let's deposit some zeros and then go back to put in some code. Let's go ahead and what? 0, 0, 0, and then here we'll put our C3, and then we'll go back. We'll just go back to 0 in this case. It's easier to type that in, and we can then examine the memory and see a C30000. If I run this program, it's looping around just like this one, but this one's looping back to 0, that one's looping back to 1. It's not so big of a deal. If I hit stop, this one stops. I hit run, it resumes. Stop, run, and you can see it stops at whatever random address has the instruction that it was executing at the time that I hit stop. Okay. Now on the bottom one here, if I reset this, it comes online in a waiting mode. If I run it, it restarts the program from the beginning because I reset the whole machine. If I reset it while it's running, the correctly working system goes into a wait mode. So there's something wrong on this system when I reset it. I'm pretty sure that I'm resetting the CPU, I think, right? Because all these LEDs light up, and these are physically connected directly to the S100 bus. So it's acting like I've really reset this machine. External clear, when you press this down, is a different kind of reset that sends a reset to the cards in the system that allow it to do a reset that's not quite a power on, full power on type of reset, which is what I do generate if I push this one up like this. So there's something wrong with this one. It does not ever want to stop. I keep hitting stop, it won't stop. I keep hitting reset, it won't stop. But if I hold down the stop and I hit reset at the same time, I did it once and it didn't stop. I do it a second time, third time, fourth, fifth, sixth. Finally it stopped. So, something's wonky going on here. Now the memory still has its value in it, which is great. So it's not like there's a power glitch or something. Well, there could be, but the memory in this system is retains its value even when we're playing with all these and having wonky situations go by here. So there's something going on with either the front panel here or the CPU card.
So step number one, let's get the unit up on the bench here and have a look-see inside here at what might be physically messed around. Well, let's take a little bit closer view of just the front here. Here's the rib, and I just unplugged it. There's a connector right here. This runs the 8 data lines from the CPU card, which is right here, over to the front panel, and you can see this line right here. The circuit board that is the has all these switches and LEDs and stuff mounted on it for the front display here. Okay, so the CPU card, we can pull this out, give it an eyeball here. Couple of tantalums here ready to explode in our face. I'm surprised these didn't blow. Those must be pretty good ones. They've held up for a 45-year-old machine here, right? One of the years, there should be some dates on here. I don't know how well this will show up on the camera. It says 1975, IMS Associates Incorporated, Revision 4, with the white ceramic case on the chip with a gold cap over the chip area. And boy, look at these resistors right here. These are pull-up resistors on the data bus. The solder job here obviously is not optimal. This solder is okay on this side of the board, but on the other side it kind of came through and made weird gloppy things. And I wonder if, you know, maybe it was okay for a while, or maybe there's just, you know, these are dirty or something. This is, I can see gold in there. This is gold plated socket here, but these through holes, maybe the plating is messed up or something. Maybe whoever soldered this, because this is not a very good job on there. Maybe they messed up the through holes and it used to work, and then after a little bit of oxidation, it stopped working. I can see some bad joints all over the place, really. So who knows? Maybe, yeah, maybe we'll tune up some of these solder joints, and maybe that'll fix our bad data bits. Now, this is a memory card. This is obviously not original if you know anything about the era. Well, is there a year on this one? What do we got on here? This is a much newer board than 1975. Processor, copyright 1976. Yeah, a whole year. What difference a year makes, right? This is a, looks to me like it's probably a 32K board. 1, 2, 3, 4. These are, what are these? Are these 2102s or what is this? Well, it does say offset and address. And if it's 32K, there'd be a single bit to choose which the address of the board is. So maybe this is a smaller board. It would be hard to get a board that big in 1976. I'll bet these are 1K by 1 bit 2102s or something. Yeah, my eyes are just good enough to make out a 2102 on there, which means 8 chips here is 1K byte. 2, 3, 4K times 2 columns. This is an 8K board. That's what this thing is. Not a bad buy for that era. Revision C. And it obviously works because we were able to store and read data back out of this thing. Fully static. I suspect that the weirdness with the data bus is not related to this board here. I'm looking at these pins here. These are all gold plated and they look fairly nice, fairly clean. This board I pulled out of a different system. I don't remember. Actually, I don't think this had any RAM in it when it was given to me. I think it just had the CPU, and that was it. So, what else do we know about this? There's the amount of dust on this backplane here is enormous. It's just dirty, absolutely a filth and muck in here. Okay. It could simply be that this is so dirty that half the data lines aren't even connecting through to the front panel, either because the CPU or memory wasn't plugged in well enough or the front panel itself. We'll take this apart and have a closer look. The front panel here is exactly the same as one of these boards. It's just longer. Okay, and by the same, I mean it has the same connector, and it plugs into this the backplane just like every other board. So in order for the front panel to see what's going on, it gets the data from this cable and every other signal directly off of this backplane bus. Here's a close-up view of the front panel, the board that's in the front panel. Look at that thing there. I mean, the focus is maybe a little off there. You can really see the rust on those pins there. That's just, yeah, the amount of Nasticosaurus Rex on there. Oh, yeah. Yeah, we may have to clean up some of that. Maybe that's why some of this isn't working. And you can see the amount of dust and crap on these connectors. Ugh, the amount of crud on my fingers. Absolutely awful. This is like a revision 1 motherboard here. Yeah, look at that. Rev 1, it says right here, whatever, EXP22. Expires in 2022. Maybe that's when it's not supposed to work anymore. Yeah. Yeah, you can see the amount of crap all over this thing. Let me see if we can focus as good as possible there. Yeah, there's a bunch of screws missing in there. Not sure what that's all about. And at that angle, you can't really see this bolt right here. Oh, yeah, look at this. Let me grab a screwdriver. Oh, man. Yeah, the bolts, this thing is half sticking out. It's not even a bolt, for crying out loud. Look at this thing. It looks like it's a wood screw. Going into metal. You know, I guess that's self-tapping, all right. Oh, man. Yeah, and if I look down in there, oh, my gosh. This is awful. I think this thing self-tapped right into the aluminum frame. That's nice. And this gasket here, grommet or whatever, is all dried up and crumbling on there. Who knows? The whole motherboard is like sitting right way down on there. I don't know if I can flip this thing up or not really, but the amount, it's not set off very far from the case. That aluminum that you see there right below the circuit board is like maybe 2 millimeters away. My point is these connectors here have pins that go through the board, and they're obviously soldered on from the other side. It makes me wonder if some of these pins, or one or two of them that are not working right, could be shorting against the case. So I'm going to have to take this whole motherboard off. We'll probably have to hit it. Maybe we'll give it a nice bath with this stuff. We'll have to clean up all the connectors on this thing. Give it a nice tidy wash. All right, let's try to get a bird's eye view again here. This power supply in here, this is a very old edition of this system, by the way. Not that this, I think, has any real problems, but normally the power transformer's in the middle. There's a giant PC board over here, and the capacitors have like a piece of metal that's got some like double-sided tape that hold them together. And in fact, the newer one has two giant caps like this on the 5-volt rail, and each one of these is for the plus and minus 12 volts. So and plus, by the way, the serial number on this thing is like 1572 or something like that. So this is like under 2000. This must be like the first draft of this design. So even among the IMSAI 8080s, this one is pretty old. The point being, of course, that everything about this is, looks like it's early draft, okay? All right, so if we tip this up like this, you can see that there's some bolts here. These bolts are holding on this gray panel here. Get this over here. That is the bottom part that goes below these switches. It actually weighs a lot. All right, so what we need to do is remove this panel down here to get it out of the way. Once that's out of the way, we can take out there's some more bolts on the front here that hold this plastic on, so we can reveal the circuit board inside here, pull the circuit board out of the motherboard, and then we can go at the motherboard and see if we can get that out of here, and clean it all up, put it all back together again, and fingers crossed, hopefully it will work. And of course, we also need to see what's going on with this board. As we saw, there were some pretty crappy looking pins on some of these chips. And again, if the soldering on the front panel here is as good as it is on the CPU, then maybe something didn't stand the test of time and just needs to be tuned up a little bit. Well, I don't think we got a lot to lose. Let's open her up. Of course, if we forget how the thing works, as I mentioned before in my video, the manuals for this thing have so much detailed information about which washers even go on what bolts and stuff like that. Of course, the manual that I have is for my other the other IMSAI 8080, the newer model. This one might actually, I don't have a manual for this older edition, so maybe I won't be able to figure out where those wood screws belong. Now, the power cords on these things are permanently in there, which are really annoying. They don't have the kind that come off like modern power supplies. So, oh boy, here we go. There's our front panel, a little more exposed, and come on over there. There we go. You can see the motherboard right there. Okay, so the front panel plugs in right down here. We have to get the front panel up this way. So now we need to remove these like crown bolts in here, little Allen wrench bolts on the front here. I sincerely doubt that those bolts are metric. Not in 1975 USA. No, these are going to be SAE Imperial units. There we go. That's a 1/16. There we go. And these are ball end Allen wrenches that are much easier to use than the regular ones. Now, I'm concerned, I don't know how well this camera's picking it up. There's a bunch of spacers right in here. When I take this bolt out, the spacers might fall. In fact, I'm sure they will. I'm going to leave the bolt in there. I'm going to unthread it from the metal, but I'm going to leave it in there so that I don't have to find the spacers on the floor underneath my workbench for the next 3 hours. Okay. Interestingly, these bolts, the heads on these bolts are in much better condition than the ones on my newer model IMSAI 8080. The newer model ones have a little bit of rust peeking around the edges of the bolt heads. Now, if you're going to do this to one of these, just be really careful you don't break off these switches. Really. You can't buy them, even if you try to find them on eBay. It looks like the colors don't match right, and they stick out. That you could break them off real easy. And even if you buy the ones that look like crap, they charge you like $5 a piece just for the plastics, right? So don't clunk the thing around and break it off. I say right before I risk doing something similar. So do as I say, not as I do. All right, it looks like I can just pull this thing straight up. There we go, and out of the motherboard there. Okay, so this is loose, and this is your 110 volts AC. All right, so when you're doing this, you want to make real sure that you are not plugged in. Okay. Oh no. And the spacers are starting to fall off the backs of the screws. So I got a little plastic tray here, like this, all right? So what I'm going to do is I'm going to take off very carefully all the little plastic pieces. So here's the plastic, all right? So the bolts are in here. I'm going to take the rest of the plastics off. And of course, the way this thing is built, the back of this is red. I don't know how well that shows up. It looks okay, I guess, in the preview monitor. There's a red piece of plastic back here. There's a piece of paper, and then a clear piece of plastic, and you can clearly see that the clear one is much thicker than the red one there. All right, so at this point, if I leave it sitting like this, the bolts won't fall out, and nothing will fall off of them. So I'm going to set that aside, and hope I don't lose that. Okay. All right, so let's go ahead and move that back a little bit. Have a closer look at our front panel here. That's interesting. The heatsink is squished on this, obviously to make it fit so it doesn't hit the plastic front panel in here. Man, the amount of dust on this is enormous. I'm not seeing any exploded tantalums in there. There's two of them right over here by the power. Two kludgy wires in here. And then another one over there with no insulation on it. This is somewhat unfortunate. If it's super old and it predates the manuals, the gold looks good on there. I don't know about this other side. We may have to clean this up with some 8,000 bolts to hold this bracket on here. I'd rather not have to take all that apart. I might have to get under... Oh. The chips are underneath these switches in there. So I certainly hope I don't need to actually... I don't want to be poking around under that. It would be nice not to have to do that. Wow. Well, again, this gold looks really nice. Of course, that's why they use gold, right? It doesn't tarnish. But it is going to collect, gunk, grease, and dust and stuff like that. Well, this looks to me much better than the CPU card in the backplane. By far better. Okay? So I think what I'm going to do is I'm not going to touch this at all. I'm going to just leave it over to here. We have to take it off anyway, so it's all right. Because this backplane in here, to me, looks awful. So I'm going to take this whole backplane out. I'll have to take the wires and stuff off of here, and then we can just take it over to the laundry tub and just spray it down with the contact cleaner. And wow, I'm going to have to... cleaning out these connectors is a nightmare because there's all these little metal fingers on each side of these. This might take some time to deal with a gentle cleaning with a cloth or something. I might be able to just hit it with the cleaner, hold it upside down, like just wash it, and then hit it with some air just to get the crud out and not actually have to really rub it or anything like that. Maybe that's the way to go. Now, of course, now that it's all opened up, I can see something here that, let me see if I can, I got to get the board out of the way here. I'll just put it back in the connector for a minute. If we tip this way up, if you can see right here, you see how this metal thing goes over and then down when it goes over to here and then back up again? That gives me much better hope that the pins on the connectors, actually I can sort of see them in this angle, but I don't know if the camera can get in there. The pins that stick out on the S100 connectors go into this empty space. I'm feeling much better about the way that this bracket is wood screwed onto the PC board is wood screwed into this, because that means it's not likely that the S100 connectors are actually shorting out to the frame. I thought it was a flat piece of aluminum underneath there. Nonetheless, however, these wood screws in here are just awful. Come on, guys. They will self-tap. I'll give you that much, you know. Before we start playing around with the soldering iron, let me at least take these off. We might be able to get the... Oh, God, this screw here is even crooked, for crying out loud. Nice. Jeez. Yeah, look, these are just awful. They're on an angle. This has got to be at least 4 or 5 degrees off of straight. I mean, at least these grommet thingies aren't all falling apart like the first one did. It just cracked and fell apart. I'll have to put some, I don't know, plastic wash. Oh, yeah, this one just shattered. Oh, man. It's just all broken. Yuck. That's nice. This screw doesn't even match the other ones. The head on this is completely different. It doesn't even fit my screwdriver. Yeah, this one looks different as well. So in like $1975, this is obvious. I mean, I hope IMSAI did not put this together. This should better been a kit that somebody put together. It's just so bad. So it looks like, you know, if you buy this, I think you got this, the front panel and the CPU, no RAM, no other, no other cards. You know, the power supply case, the motherboard, CPU, front panel. For about $550 or $600, according to the ads that ran in Byte magazine back then. And in $1975, translated to today, that's like $2,000. And you know, so they put it together like a bunch of idiots. Here's a nice, you know, countersink wood screw. So they obviously lost the screws. Or some of the screws, and substituted whatever they had in the high school shop when they put this together. There's all these DB9s back here as well. I don't know if you can see that here. Let me pull this up. Somebody cut these cables off. I didn't. This is just how I got it. Some 20-some years ago, but it's been sitting around down here. These are in the way now, and all the cables are cut off, and these are the crimp-on types. So even if I had the insertion tool, I don't know if that on a DB9 will let you get the thing back out or not. And these have no value to me, so I'm going to just take all these off and chuck them. Jeez. And the front panel's still up here and loose, and I don't want to risk messing it up. But this whole thing, some of these DB9s back. Well, let me see if I can tip it up a little bit. The 10-ton transformers right there. These are all bent up and crooked. Yeah. Someone learning how to use a wrench put these in. Now, I'm going to save these jack posts. You never find one when you need one. Boy, that just... There you go. So somebody mounted this one backwards. It's all bent up and everything. Let me see if I can... When I get it out of here, I can show you. Is this going to show up on the camera? Okay, where is... I don't know if you can see that this end of it's all bent up. And of course, they stuck it in this way. And the way these are manufactured, they're supposed to be stuck in from this side, because this end is wider and longer than the side over here where you plug it into the instrument. So whoever mounted this was clueless dope and put it on the wrong side of the case. But you know, I gotta give them kudos for using jack posts, because you know, then the DB25 that you plug in, if you don't use these things, they you know, then they don't have the screw threads to hold the connector in. So even if it's, you know, bent and crooked and looks like garbage, it will have been able to, if you wanted to, you could, you know, thread the wing nuts on the DB25 connector into the case to keep it in there so it doesn't pop out. All right, overly creative mounting of DB25s is done. Let's see if we can get this thing to come up. Have a look-see at the bottom of it before we take to soldering iron activities. Don't know if the wires are going to be long enough. Come on, please, let me see in there. Oh, crap. It's all hung up. And of course, it's ever so slightly too long. Maybe I can bend it a little bit. Yeah, no, not a good idea. Anyway, wow. Yeah, so it's, maybe this. Jesus. Thanks a lot, guys. Well, if I look around inside here, I don't see any scratching. Oh, I see a lot of nasty dirt. Do not reach in there. But I don't see a bunch of scratches like, you know, the pins of these connectors are reaching down too far and striking the bottom of the case. So this thing is just absolutely covered with nasty dust and dirt and grime. So I'm going to have to disconnect all these wires. Luckily, they're screwed onto these capacitors over here. So they're all color-coded. And, I mean, they're obvious what they go on the S100 bus. Anyway, your plus and minus 12, the whites are your 5s, and your blacks are your grounds. Excuse me, that's how much dust is on this thing. Now, if you're going to do this, I learned long ago, you take photos of what is there before you muck it up. Okay, so you make sure you got all the colors just right. Okay, so I'm going to take a high-level photo, a nice close-up photo that has all the colors of the wires in there. All right, now I'm going to go ahead and preview them to make sure that I actually come on. Yeah, I want to have 80,000 menus. Just zoom this, please. To make sure I can see the colors. I can clearly see the orange, the white, the black, and the yellow on here. All right, so yes, I have viable documentation. Which ones go back where they used to be? So these two have a spade lug on there. Oh, this is so annoying. I'll bet anything that when you get this kit, it comes with crimp-ons that you crimp on. And whoever did the crimping is the same dingus that probably put the connectors on wrong. This has a round lug, not a spade lug, okay? And therefore, you have to take the whole bolt out. And that's okay, But these two, so what he did here is he crimped the one that goes to this PC board with one of the wires that goes onto the backplane, rather than, like a sane individual, crimping the two backplane wires together on the same lug. So I cannot do this without cutting this or keeping the whole unit together when I take this board out. It's just so dumb. Yeah, that shows me a lot. No wonder the thing doesn't work. Jeez. That is a beautiful, yeah, that's great. Complete lack of understanding of what's going on. Wood screws in the back plane. Oh my. I'm sure the instructions say, pick random lugs and crimp them onto the wires in any order that you think looks nice. Do it based on how you feel. If you had eggs for breakfast, use the spade lug. If you had cereal, what do you call these? These aren't spades. These are, I don't know, round holy ones. Beats me. I don't actually see the giant pluses and the minuses on these capacitors either, by the way. I'm sure they're labeled underneath all the dirt. But by keeping the black wires where they were, and plus I got the pictures, I am essentially marking. Boy, that screw doesn't feel right. It's as if I'm threading it in crooked, which is something you don't want to do, because you're not going to have, you can't replace, once you wreck the threads in there, you're done. So, at this point, I should be able to remove it if the person that created it wasn't an annoying person. Crimp them all. I should be able to get it up on an angle, though, now. There's enough wires free for... Come on. Well, maybe not. I do have the slack. What I need to do is cut the wire ties. Now, when you cut wire ties, make sure you don't cut the wires. Famous last words, right? It would have been nice, rather than putting two wire ties right next to each other, just like this, with every wire in it. I'm sure that's also not in the instructions. It's probably put one on all the AC wires, and then put another zip tie on all the DC wires independently. No, I'm going to just put two right next to each other, where one of them is utterly pointless. Look at this. Unbelievable. I don't know if I got enough detail with this camera. Just stupid. I guess, it's the gift horse in the mouth, right? I got it for free. But I can get some entertainment value out of it too, right? We'll see how good I put it back together again when I'm done. Oh, that's always a good one. Oh, I put it all back together and I forgot to put the hood on the connector, which means you have to rewire the whole universe or something. Yeah, I've got a couple of connectors that have black tape on them instead of the hood. After 30 wires that needed to be soldered on or something, and I'm like, I'm not going to redo that. Been there. Okay, come out of there. All right. Well, plenty of flux on there. Still a lot of flux on there. Jeez, little burn marks. Yeah, this was definitely put together by the owner, by a consumer. These little gasket grommet thingies, most of them that are actually here still look okay. I'm not at all happy with the way this board looks here. I'll have to get a close-up of this here. This is... wow. So, if any of these grommets fail, these vias are going to set down on the grounded case. That's great. Over here, this is all just ground anyway, so even the missing grommets over there, if this made contact, it'd probably okay. But what I'm going to do is I'm going to get some nylon washers, or I could actually 3D print some replacements with like PETG or something like that, which is not going to dry out, or even if it did, it wouldn't dry out in my lifetime. So I'll let the next pour sap deal with it. Wow. I see a missing. Oh, look at this. There's pins that aren't even soldered in. They missed some. Oh, man. Now I'm going to have to check every one of these solder joints. That's great. Yeah, that's really nice. That might actually be soldered in. I don't know. It certainly doesn't look good. And while we're here, we should have a really good close look at the main front connector where the front panel goes. I mean, on the one hand, you can always not use one of the main connectors if it's a problem, right? You know what's interesting about this front panel one right here? If you look at it, you'll notice a distinct difference in soldering quality. A serious difference. Actually, every other connector in here is perfect and has all the crud cleaned off of it, the flux, and then the flux ones are just all over the place, and they're all messed up. And back in the day, it was not at all uncommon to buy systems that had every other connector in them. And if you wanted more, you'd put the rest in yourself. So it makes me wonder, when he bought this, maybe well, I don't know. They're not soldered in that great either, but it might have been, my point is, it might have been that IMSAI sent it with the odd number connectors in there, and then the evens were added later, or it was a kit and one person added them and another person went through later on and added the other ones on their own. When I suppose when they added the second batch, they did not have enough money for flux remover. That obviously is the story. That's their story, and they're gonna stick to it. All right, let's see if we can free up this front panel. My iron nice and hot here. This is definitely going to be lead-based solder in this era. Now, this is AC, so it's not polarized, so I don't have to remember which one goes where. And it's obvious that these brown wires go to the front panel. Be free, mein front panel. Well, yeah, so I don't know what I want to do about these wires. I want to cut them and put new lugs on there. I don't even think I have any spare lugs around. I guess I could unsolder them. Again, making sure I remember where they go. This is not too bad. You get your plus and minus 12. I can use a meter to figure that out. There's a lot of wiring here. There's just so much mud. I don't want to have to take every single thing out, but it looks like I'm going to have to. I'm never going to do this again. This is the last time I take this thing apart. The one and only time, right? Is that really what I want to do? I want this out of the way, so if I can fling this around, I'm not breaking everything. And clotheslining all the cables and all these other boards. That seems like the right thing to do. I'm going to have to go out and buy some lugs or solder these together with some heat shrink. Is that really what I want to do? Like, it doesn't seem like much of a risk. I'll give myself some slack. I could heat shrink these back together again. There we go. Now this is free. Out of the way. No. We're just down to the 10-ton transformer. And this thing really does weigh a lot. Oh, oh man. And there's all this broken plastic from those grommets falling out of it now. Okay, so and of course I tipped it in the direction I can't reach. Oh boy, oh boy, oh boy, come on. And the cord that can't be removed. That's great. Okay. Awesomeness. And now we have Phillips. These, of course, being the finest screwdrivers $1 can buy. Oh, at the local... Where do these things come from? I think these are the house brand from, like... oh, there we go. Harbor Freight or something. I mean, they're good for light duty. I'm not sure I'd use them for automotive work, though. You know, I'm glad that these all these bolts didn't get oxidized, requiring every one to have a nut driver on them. They saved that for the ones that were unreachable only. I should probably test these. Have a look-see at the electrolytic. Test that. Make sure that it has a pretty high series resistance, because if these are going to go off like a mortar if these things decided to blow up. Now, before I even ran this, I don't know if I mentioned this earlier. I put this whole thing out in the garage and let it run for 6 hours while I was nowhere near it, just to make sure. I didn't want this thing, I didn't want my face anywhere near this when it was on that first run. So in a lot of ways, I'm pretty confident, well, in one way, I should say, I'm pretty confident that these are okay capacitors. And they ran out of Phillips screws. It's great. Shows me a lot. This has obviously been through different hands over the years, perhaps. Oops. Either that or the original owner is a complete dingus. Never underestimate the probability of a dingus being involved. Even if the dingus is one's self, we all get lazy. Oh, I'm never going to have to do this again, you know. My brother and I are always kidding around when we do something on our homes. Going to fix that or this or whatever. We, of course, don't have the right tools, or we didn't get enough of this or that, or the amount of trim comes up a foot short. Let the next owner deal with it. Hide it behind the door or something where no one's going to notice. And let the next guy worry about it. All right, now that all this crap is out of the way, we can remove the other power supply board. Oh my God, I should have just taken the transformer off before I did anything. Jeez. All right, these are almost out of the way. I guess I can take the wires off at this point. I wish I'd feel a lot better if there was a giant minus on there. Oh, what's this? There is a plus right there. Is that visible on there? Maybe not, but there's a big plus right on the capacitor. So that's fine. I know which is which now. At least on this one. God, you know what? I didn't screw this thing up. The previous dingus did. What a jerk. Or I did. This screw does not go in that the right way. That's awesome. That's just great. Look at that. Jesus. I don't know if that's visible. No, it's not on the camera, but this is not in straight. That's awesome. It's like cross-threaded. No wonder I couldn't get it to go in, because I was trying to put it in straight. What was I thinking? You know, is it really worth it? I have two. The other one works. I can't help myself. Yeah, what a way to spend the evening. Honey, what did you do this evening? Well, I cleaned the mud out of a 45-year-old unfunctioning computer. That's nice, dear. Jeez. Right now, it looks to me like the transformer bolts have nylocks on them. So I'm not going to be able to get these off by hand. Every one of them is going to have to be held with the pliers. And the bolts are like a mile long. So even when they're, starting to get loosened up, you'll have to take... Oh, man, and they're rusted. Oh, geez. This is great. Oh, well, at least they're coming off. Oops. Come on. It's a gorgeous thing. Oh, my God. It weighs a ton. Well, they didn't want to get the same kind of reputation that the MITS Altair guys had. The transformers in the Altair were tiny. Well known to be underpowered once you added a couple of boards. So, I mean, look at this size of this thing. Wow. There you go. There's a big old EI transformer 5 or something. Okay, so there's all this. And, of course, the annoying cord that's not ever... I could take the strain relief out, but then I'd have to unsolder it from here. And don't these stupid cords. All right, this is just dumb. Don't build things. Is that on camera here? Are we on here? Don't build things with these idiot cords, okay? That just are in there like this. This is stupid. Not for your home stuff. And nowadays it's very rare. I don't want to cut up I don't want to destroy, its authenticity. So I guess I'll leave that. What I could do is unsolder it from the board here. That way just all this is together. Yeah, I'll do that. It's easy enough to put back in there. All right, one more photo document. Actually, I can see in the PC board that there are letters where the wires go. Let me see if I... Should be like G, W, and B. Look at that. It's the colors of the wires, right? So let me see if I can get a photo with the letters on it. And the colors to confirm that they at least hooked it up right. I don't want to tear the traces off. It'd be nice. This is a double-sided board, so you got to be careful that you don't pull it off. And on the other side, you pull the wires out. Ouch. Come on, Mr. Ground. Come out of there. There it goes. Fine. Let's go ahead and unsolder the fan as well. I may or may not regret this. If this doesn't go back together again, we'll have a fire sale on eBay or something. IMSAI kit. Put all the parts in a little plastic bag and mail it off. Dirt and all. Authentic. Aged. Well aged. Dirt, no extra charge for the dirt. Now this disaster area is free. Now this is like 1 ounce compared to what it used to be. It weighs nothing now. Well, the good news is I've come this far. At least it's going to be clean. Thanks for watching. I'll see you next time. Maybe we'll get this thing put back together again.